I didn't slam any doors or send angry emails. There was no dramatic speech about company values or desk-clearing tantrum. I simply stood up from my workstation at 2:47 a.m. on the last day of the quarter, unplugged my radio, and walked away from 18 years of loyalty that had just been valued at exactly $30,000 less than some kid fresh out of college who couldn't tell the difference between a torque wrench and a tire iron. My name is Howard Barnes. I'm 49 years old. And this is how I learned that teaching someone everything you know is the fastest way to make yourself expendable. The whole thing started about 18 months ago when Great Lakes Automotive brought in Mason Kelly, fresh from college with his industrial engineering degree and a head full of lean manufacturing theories. He was 26, ambitious, and spoke fluent corporate buzzword, the kind of guy who could turn the lines running slow into, we need to leverage process optimization to maximize throughput efficiency. I'd been at Great Lakes for 18 years by then. Started on the line right after high school, worked my way up to production operations manager through pure sweat and learning every machine, every process, every quirk of our operation. We manufactured brake components for GM, Ford, and Chrysler. The kind of parts where precision matters because people's lives depend on them working perfectly every single time. Back when I started, Great Lakes was a smaller operation. Maybe 150 employees, family-owned business where the owner knew everyone's name. Old Man Harrison built the company from nothing in the 1970s, understanding that automotive suppliers succeed by being reliable, not flashy. He promoted from within, valued experience, treated workers like humans instead of spreadsheet entries. I remember my first day on line 2, working the brake disc finishing station. The machine was older than I was, temperamental as hell, but when you learned its quirks, it could hold tolerances better than equipment, costing 10 times as much. My supervisor then was Bill Crawford, a guy who'd been there since the company started. Bill taught me that manufacturing isn't about following procedures blindly. It's about understanding why those procedures exist. See that vibration when the spindle engages? Bill would say, pointing at subtle machine behavior I couldn't even notice yet. That tells you the chuck's wearing. Replace it now, prevent downtime later. Run it until failure, and you'll shut down production for 6 hours while we wait for parts. Those lessons stuck. Over the years, I learned every machine's personality, every process's potential failure modes, every safety protocol's origin story. Most of those protocols existed because something had gone wrong before, sometimes expensively, sometimes dangerously. Great Lakes grew during the 2000s automotive boom. We expanded from 150 to 400 employees, added new production lines, modernized equipment, but we kept that family culture, that respect for institutional knowledge. When problems arose, management asked the people who actually ran the equipment what they thought. Revolutionary concept. By 2010, I was a shift supervisor. By 2015, assistant production manager. The promotions came slowly but steadily, based on competence rather than credentials. I'd earned respect by being the guy who could diagnose problems others missed, who could keep lines running when everything seemed to go sideways. Linda and I got married in 1999, when I was still a line operator making $14 an hour. She was teaching elementary school, making barely more than I was. We bought a small house, modest payments on a 30-year mortgage, planning for kids we hoped to have someday. We weren't wealthy, but we were building something solid. Michelle came along in 2004, Owen in 2005. Irish twins, Linda called them. 13 months apart, which meant double diaper duty, double college savings needs, double everything. But watching those kids grow up was worth every sleepless night and stretched budget. The early 2000s were good years for Great Lakes. The automotive industry recovered from the recession, manufacturers were investing in domestic suppliers again, and our reputation for quality opened doors with major OEM as Harrison's son took over daily operations while the old man stayed involved strategically. The transition felt natural, continuity preserved. I made production operations manager in 2017. By then, our $200 million operation ran on a complex web of production lines, quality control checkpoints, and safety protocols that I'd helped develop over nearly 2 decades. When something went wrong on the floor, and in manufacturing something always goes wrong, I was the guy who could diagnose problems in minutes that would take others hours to figure out. Not because I was smarter than anyone else, because I'd seen every possible failure mode at least twice, had learned from mechanics and engineers and operators who'd been solving these problems since before lean manufacturing was a buzzword. Experience matters in manufacturing. Lives depend on parts working perfectly, and parts work perfectly when people understand not just what to do, but why they're doing it. Our operation wasn't glamorous work, but it was important work. When our brake components failed quality checks, we scrapped them. When automotive suppliers cut corners, people die in accidents. We took pride in that responsibility, in being the kind of company that automotive engineers trusted with critical safety components. Manufacturing isn't like office work, where problems can wait until Monday. When our lines go down, we lose $15,000 an hour. When we can't ship orders on time, customers start shopping around for new suppliers. There's no, "we'll fix it later" in automotive. Downtime is measured in dollars bleeding out, while everyone stands around waiting for someone who actually knows how to solve the problem. That's where institutional knowledge matters. Textbooks teach theory. Experience teaches reality. The difference between understanding something well enough to present it in a PowerPoint slide and understanding it well enough to fix it when everything goes sideways at 2 a.m. on a weekend, that difference is measured in years, not credit hours. Which brings me to Mason Kelly, Process Optimization Specialist. Nice title. His first day, Sharon Foster, our operations director, asked me to show him around the floor. "Give him the full tour," she said. "Help him understand how everything connects." Sharon had been with the company for 8 years, worked her way up from quality control supervisor to operations director. She understood manufacturing, respected experience, knew the difference between efficiency improvements and efficiency theater. When she asked me to mentor Mason, I figured the kid might actually learn something valuable. So I did. I spent hours with the kid, walking him through our production processes, explaining why we couldn't just implement every lean manufacturing idea he'd learned in textbooks. Our brake component tolerances were measured in thousandths of an inch. Our quality checks caught defects that could cause brake failure. Our safety protocols existed because I'd seen what happens when shortcuts get people hurt. I showed Mason Line 3's disc brake manufacturing process, where raw steel blanks got machined into components that would stop 4,000-pound vehicles traveling at highway speeds. The margin for error was essentially zero. A brake rotor with improper surface finish or dimensional variance could cause brake fade, vibration, or complete failure under stress. "Why do we run this additional surface roughness check?" Mason asked, pointing at a quality control station that measured surface texture in micro-inches. "The previous machining operation should have achieved the specification." Good question. I explained how metallurgy works in practice versus theory, how tool wear creates gradual surface finish degradation that stays within acceptable ranges for hours, then suddenly exceeds specifications, how catching that transition early prevents scrapping entire batches of expensive components. But statistically, Mason said, consulting his tablet, we're only catching defects in about 2% of parts at this station. That's a 98% non-value-added operation. That's where theory meets reality in manufacturing. Yes, 98% of parts pass that inspection, but the 2% that fail would cost us $50,000 in scrap material, plus potential liability if defective parts reach customers. The inspection cost may be $200 per hour to operate. Even a business school graduate should be able to do that math. Mason was eager to learn, I'll give him that. Asked good questions, took detailed notes, seemed genuinely interested in understanding the complexity of what we'd built over the years. He reminded me of myself when I was starting out, hungry for knowledge, wanting to make things better, convinced that fresh eyes could see solutions everyone else had missed. The difference was that when I started, I spent months just watching experienced operators work before I suggested any changes. I learned why things were done certain ways before proposing different ways to do them. Mason had the confidence that comes with credentials but not experience. By month 3, something shifted. Mason started sitting in on management meetings that I'd never been invited to, started talking about process improvement opportunities and efficiency optimization initiatives. He'd throw around phrases like leveraging existing operational knowledge and building on institutional expertise. Corporate speak for Howard taught me this, but I'm the one presenting it. Don't get me wrong, the kid was smart. He understood business strategy in ways I never would. He could take my explanations about why we ran certain safety checks and turn them into PowerPoint slides that made executives lean forward and nod. He knew how to package solutions in language that management wanted to hear. But there's a difference between understanding something well enough to present it and understanding it well enough to fix it when everything goes sideways at 2 a.m. on a weekend. Mason lived in the first world. I lived in the second. The presentations started in month 4. Operational Excellence Initiatives was the first one I heard about. Mason had identified $2.3 million in annual savings opportunities through process optimization and waste elimination. The numbers looked impressive in slide format, backed by charts and graphs that made efficiency improvements seem inevitable. I recognized most of his recommendations. They were variations on suggestions I'd made over the years, dressed up in consulting language. Reduce redundant quality checks, eliminate non-value-added activities, implement predictive maintenance schedules. Perfectly reasonable ideas that I'd proposed, through normal channels without much fanfare. The difference was presentation. When I suggested reducing inspection frequency based on statistical process control data, it was just Howard making another practical suggestion. When Mason presented the same concept as implementing risk-based quality assurance protocols to optimize resource allocation, suddenly it was innovative thinking worth executive attention. By month 6, Mason was getting invited to strategic planning sessions. By month 9, he had his own budget for process improvement projects. By month 12, executives were praising his innovative approach to production optimization. All of it built on foundations I'd explained to him during those early training walks. I didn't mind initially. Training younger people was part of the job. Seeing someone you've mentored succeed feels good, and Mason always mentioned collaboration with the production team when presenting his projects. Technically accurate, diplomatically worded. The first real implementation came in month 14. Mason's Efficiency Enhancement Initiative for Line 2's brake caliper production. He'd identified opportunities to reduce cycle time by eliminating what he called redundant verification steps. The math looked solid. Removing 3 quality checks could increase throughput by 12% while maintaining statistical quality confidence. I reviewed his proposal carefully. Technically sound, properly researched, backed by solid data analysis. The problem wasn't his calculations. The problem was that his calculations didn't account for variables you only learn through experience, like how Line 2's casting supplier sometimes delivered material with inconsistent metallurgy that only showed up under certain stress conditions, like how the hydraulic system on that line occasionally produced pressure spikes that affected seal integrity in ways that didn't register on standard monitoring equipment. Those quality checks Mason wanted to eliminate weren't just verifying dimensional specifications. They were catching problems that happened maybe once every 500 parts, but when they happened, the failure modes were catastrophic. A brake caliper that looked perfect but had micro cracks from stress corrosion would pass dimensional inspection but fail catastrophically after 20,000 miles of service. I tried explaining this during the implementation meeting, raised concerns about failure modes that weren't captured in the statistical analysis, mentioned specific examples of problems we'd caught with those supposedly redundant checks, suggested a pilot program to validate the optimization before full implementation. Howard raises some valid points, Mason said diplomatically, but we need to balance theoretical risks against measurable productivity gains. The data supports optimization, and we can monitor quality metrics to ensure performance. Sharon backed Mason's proposal. The numbers looked good, the presentation was professional, and efficiency improvements would help hit quarterly targets that were looking tight. My concerns got noted in the meeting minutes as operational considerations to monitor during implementation. The optimization went live the following Monday. For 2 weeks, everything ran smoothly. Cycle times improved exactly as projected, quality metrics stayed within acceptable ranges, and Mason's initiative looked like a clear success. He got invited to present the results at a company-wide operations review, positioned as a case study in data-driven process improvement. Then Line 2 started producing brake calipers with hairline cracks in the hydraulic chambers. The cracks showed up in the quality audit 3 weeks later. Ford's incoming inspection caught them during routine sampling. Hairline fractures in the hydraulic chamber walls that weren't visible to standard visual inspection, but showed up under dye-penetrant testing. The kind of defects that would cause brake failure after months of thermal cycling. And hydraulic pressure stress. We had to recall 2,400 brake calipers that had already shipped. Ford suspended our delivery approvals pending a corrective action investigation. GM launched their own audit of our quality systems. The recall cost Great Lakes $1.8 million in material, labor, and penalty fees. Mason's $300,000 annual efficiency improvement had generated a loss that would take 6 years to break even. The post-mortem meeting was uncomfortable. Quality engineering traced the problem back to insufficient inspection of the stress relief process after machining. One of the redundant checks Mason had eliminated was specifically designed to catch stress-related metallurgy issues that didn't show up in dimensional measurements. This was an unforeseeable failure mode, Mason explained to the executive team. The statistical analysis indicated these defects occurred less than 0.1% of historical production. The optimization was based on sound data. He wasn't wrong, technically. The failure rate was low statistically. But in manufacturing, low probability events happen with mathematical certainty when you're producing thousands of parts. A 0.1% defect rate means 2 failures per 1,000 parts. When you ship 240,000 parts annually, that's 240 potential brake failures. In automotive, that's 240 potential accidents. Sharon reinstated the full quality protocol. Mason's efficiency initiative got quietly shelved. The incident report cited inadequate risk assessment of process changes as the root cause, diplomatic language that spread blame without pointing fingers directly at anyone's career prospects. But the damage was done. Ford required additional quality audits for the next 18 months. GM implemented enhanced incoming inspection procedures that added cost to every shipment. Our quality reputation, built over decades, took a hit that would take years to recover. Mason survived the recall crisis. He was young, credentialed, and hadn't technically violated any procedures. His analysis was mathematically correct. The failure was in risk assessment, not data analysis. Executive management viewed it as a learning experience rather than gross negligence. I watched him become more cautious after that. Still ambitious, still confident, but more aware that manufacturing has consequences beyond PowerPoint slides. He started asking more questions about failure modes, spending more time on the production floor, building relationships with operators who could teach him things they don't cover in engineering school. By month 16, Mason had rebuilt his reputation. His next project was a preventive maintenance optimization program that actually worked, reducing unplanned downtime by 15% while cutting maintenance costs. He'd learned to validate theoretical improvements against practical experience before implementation. The kid was growing up. Then November rolled around, and everything changed. Sharon Foster sent a company-wide email about competitive retention packages for key personnel. The manufacturing job market was brutal. Skilled operators and experienced supervisors were getting poached with offers 30 to 40% above market rates. Great Lakes was hemorrhaging talent to competitors who understood that institutional knowledge has value. Our best quality inspector, Maria Santos, had taken a job at a Ford plant for a 35% salary increase. 2 experienced line supervisors got recruited by competitors within the same month. Tom Bradley, our maintenance supervisor who knew every machine's personality, accepted an offer from a Tier 1 supplier that doubled his overtime opportunities. The talent drain was hitting our operational efficiency. Training new employees took months. New supervisors needed years to develop the judgment that comes with experience. Every departure created knowledge gaps that affected productivity and quality. But I wasn't worried about my position. 18 years of operational knowledge, perfect safety, record, relationships with every supplier and contractor we dealt with. I'd mentored dozens of employees, managed through multiple crises, built the safety and quality systems that kept our operation running smoothly. I figured I was pretty secure. That confidence lasted right up until Sharon called me on Wednesday afternoon to discuss my retention package. Meanwhile, family pressures were mounting. Michelle was halfway through sophomore year at State University, pulling a 3.4 GPA in engineering and loving college life. Tuition, room, and board ran us $32,000 annually. Owen had been accepted to 3 universities for fall admission, including his first choice that came with a $38,000 price tag. 2 kids in college simultaneously, the financial nightmare that Linda and I had been preparing for since they were toddlers, but somehow never felt prepared enough to handle. We'd saved what we could, but middle-class salaries don't generate the kind of college savings that make dual tuition payments comfortable. Linda's father, Frank, had moved in with us the previous year after his heart attack. Medicare covered the basics, but his medications cost $400 monthly out of pocket. Physical therapy was another $300. The cardiologist visits, blood work, and monitoring equipment added up to expenses that were manageable individually, but crushing collectively. Linda had reduced her teaching schedule to part-time to help care for her father. Good for family dynamics, brutal for our finances. We'd lost $18,000 in annual income right when our expenses were peaking. Every dollar mattered now. Every unexpected expense meant shifting money from savings accounts that were already running thin. The mortgage was manageable at our current income level, but we'd refinanced 3 years earlier when interest rates were low. The payment was $1,840 monthly, reasonable when both Linda and I were working full-time, but tight now that she was part-time and we had additional family medical expenses. I'd been thinking about early retirement, maybe transitioning to consulting work in a few years when both kids finished college. Great Lakes offered a decent pension plan for employees with 20-plus years of service. If I could hang on until 55, the numbers would work for comfortable retirement. But that plan assumed steady employment and reasonable salary growth. It assumed that 18 years of loyalty and competence would be valued appropriately by management who understood that experience has worth beyond quarterly efficiency metrics. Howard, Sharon said when she called Wednesday afternoon, her video background showing that professional bookshelf setup they all use now. I want to start by thanking you for everything you do. You've been absolutely critical to our operational stability. The pause that followed felt like waiting for biopsy results. I'd heard enough corporate conversations to know that everything before the word, but was just throat clearing. We're excited to offer you a retention bonus of $15,000 paid over 6 months, contingent on an 18-month commitment agreement. $15,000. I stared at my screen trying to process the number. My first thought wasn't gratitude, it was math. Cold, hard family budget math. $15,000 spread over 6 months worked out to about $2,500 extra per month before taxes. Maybe $1,800 take home after federal and state withholdings. Better than nothing, but not exactly life-changing money considering our financial pressures. I appreciate the offer, I said carefully. Can I review the full terms? Of course. I'll send everything over this afternoon. Just let me know by Friday if you're ready to move forward. After we hung up, I sat in my kitchen feeling oddly deflated. 18 years of keeping production running, of building safety protocols that protected workers, of training new employees, and troubleshooting crises. And this was my value to the company. $15,000 to stick around for 18 more months. I was still processing that when Mason sent me a text an hour later. Dude, just got off a call with Sharon. They really came through. Check this out. He attached a photo of his retention letter. Clean, unredacted, probably excited to share good news with someone who'd understand the company context. $45,000, same structure, 6-month payment schedule, same 18-month commitment requirement. But $45,000 instead of $15,000, a difference of $30,000. 3 times what they'd offered me. I read the photo multiple times, hoping I'd misunderstood something, hoping there was some explanation that would make it make sense. Different job classifications, maybe. Different market rates for engineers versus operations managers. Told you they know talent when they see it, Mason added in a follow-up text. I didn't respond. I needed time to think. That evening, Linda found me at the kitchen table with our budget spreadsheet, working through numbers, college tuition projections, monthly expenses, retirement savings that had been stagnant for 3 years, because every extra dollar went toward family obligations. How did your call with Sharon go? She asked, settling into the chair across from me with her evening tea. They offered me a retention bonus. That's great. How much? $15,000 over 6 months. Linda nodded, doing the same math I'd done earlier. Every bit helps with the kids' expenses. I showed her Mason's text. She stopped mid-nod, set down her mug carefully. Linda had been married to me for 24 years. She understood the significance without me having to explain it. The kid you've been training? The same one. We sat in silence for a few minutes. Linda's always been better at processing emotional information than me. But this wasn't really about emotions. This was about math, and the math was pretty clear. What are you going to do? She finally asked. I don't know yet, but that wasn't entirely true. Part of me already knew. Friday night came faster than I wanted. End of quarter was always our highest stress period. The automotive industry runs on just-in-time delivery, and missing shipping deadlines triggers penalty clauses that can cost millions. We'd been running 24/7 production for a week straight to meet quarterly commitments. I'd worked every end-of-quarter push for the past 15 years, not because I was officially required to, but because I was the one person who could diagnose and fix problems fast enough to keep production running. It had become an unspoken expectation. At 11:45 p.m., I got the first alert. Line 3 was showing efficiency drops. Throughput down 8% from target. Not catastrophic yet, but trending wrong during our most critical production period. By midnight, the problem was spreading. Lines 2 and 4 were showing similar drops. Quality control was reporting longer cycle times on brake disc finishing. We were looking at missing weekend shipping targets, which would trigger penalty clauses in our GM contract. I traced the issue back to a process optimization Mason had implemented the week before. His latest efficiency enhancement initiative. Another project that looked great in presentations. The optimization was supposed to reduce cycle times by eliminating what he called buffer time between operations. The problem was that those buffers weren't arbitrary. They existed to accommodate normal variations in material properties, tool wear, and environmental conditions. Mason's optimization worked fine under ideal conditions, but created bottlenecks when real-world variables introduced delays. My phone rang at 12:30 a.m. Sharon, her voice tight with stress. "Howard, I'm seeing alerts on the dashboard. What's happening?" I explained the situation. Technical details, root cause, remediation options, estimated time to resolution. The same calm, professional breakdown I'd given dozens of times over the years. "How bad is it? We'll start missing shipping deadlines by 6 a.m. if I don't fix it now. Can you fix it without shutting down?" "Production? Not safely. I can patch it temporarily, but we'll hit the same problem during the next high-volume period. Do what you have to do, but minimize downtime." I implemented the workaround, monitored the systems for 30 minutes to confirm it held, and documented everything in the incident log. Production efficiency returned to normal. Crisis averted. Another successful save that would never make it into a performance review. At 1:45 a.m., Mason sent me a text. "Heard there was some excitement tonight. You got it handled?" Like he was checking on a basketball score. Casual, detached, completely disconnected from the 2 hours of stress I'd just endured to fix his broken optimization. "Fixed," I replied. "Awesome." That's what I told Sharon when she called, that you'd take care of it. That hit me like cold water. Mason had told Sharon that he would take care of the crisis, using you to claim ownership of work he couldn't do, problems he couldn't solve, expertise he didn't possess. At 2:15 a.m., another alert fired. Line 1 was showing the same efficiency drops. Mason's optimization was creating cascade failures across multiple production lines. Our quality control system was struggling to keep up with the bottlenecks his improvement had created. I sat at my workstation looking at the alert screens, thinking about that text message. That's what I told Sharon, that you'd take care of it. Thinking about performance reviews that praised my institutional knowledge while paying me $30,000 less than the person who'd created the problems I was fixing. Thinking about 18 years of midnight phone calls and weekend emergencies that had somehow been valued at $15,000. I could fix this crisis. I could patch these systems, implement workarounds, keep everything running through the weekend. I could work another 10 hours straight to clean up the mess that Mason's optimization had created. And on Monday morning, he'd probably get thanked for his proactive efficiency initiatives while I'd get another crisis to solve. At 2:47 a.m., I made a different choice. I stood up from my workstation, unplugged my radio, left my computer logged in with alerts still firing across the screen, and walked out of the plant. For the first time in 18 years, I let someone else's problem stay someone else's problem. 6 months later, I was senior production manager at Automotive Components, Inc., a Ford supplier across town. 25% salary increase, $10,000 signing bonus, and a team that valued experience alongside innovation. Mason lasted 4 more months at Great Lakes before moving to a consulting firm. Sometimes the best career decision you can make is knowing when to stop solving other people's problems for free. A company that undervalues your contributions while overpaying newcomers isn't worthy of your best efforts or midnight crisis calls. Sometimes the most powerful thing you can do is simply stop solving problems for people who don't appreciate the solutions.